In flexible PU foam formula calculation, density is not something you check only at the end. It is something you need to set first. Once density is set, the formula starts to have a clear direction, because only then can you judge how much total foaming volume the system will roughly need. Why does this step come so early? Because most of the later calculation is built on this starting point. If the target density is lower, the system usually needs a larger foaming volume. If the target density is higher, the required foaming volume will be in a different range. In other words, only after density is set can the direction of total foaming volume really be established. And once that direction is clear, you can move on to the next questions. What range the water level should fall into, whether an auxiliary blowing agent is needed, how the isocyanate level should be judged, and what kind of exotherm range the system may enter. None of these are isolated decisions. They are all developed step by step around the target density. So the real sequence is not to look at local parameters first and then go back to patch density later. The real sequence is to set density first, then establish the total foaming volume direction, and then move on to the blowing rod and the later system judgment. Density matters not only because it affects foaming volume. More importantly, it sets a clearer operating range for many of the properties that come later. For example, a target density of around 25 kg per cubic meter and a target density of around 50 kg per cubic meter do not place the system in the same operating range at all. The total foaming test, the exotherm level, and the cell stability requirement are already different. As for the exact water level, that still needs to be judged together with the blowing rod. And further down, properties such as hardness, resilience, airflow, and compression set will also enter different balance ranges. But one thing needs to be clear here. Starting with density does not mean density is more important than every other property. And it does not mean that once density is fixed, all other properties are automatically fixed as well. A more accurate way to say it is this: density sets the boundary for later calculation and adjustment. If that boundary is not established first, many later judgments lose their reference point. This becomes even more obvious when you move toward lower density systems. In ultra-low density formulations, for example, the blowing rod, catalyst selection, and foam stability requirements often become clearly different from those in conventional flexible foam systems. That shows that a density change is not just a number change. It changes the logic of the whole formula design. In the next episode, we will continue with the next question: how is total foaming volume established, and why is a water-only system only a calculation starting point? If you want to avoid common misunderstandings in flexible PU foam formulation calculation, comment mistakes below. We'll share the document, 8 Common Misunderstandings in Flexible PU Foam Formulation Calculation. Or you can download it directly from the link in the video description.